Today we move on to topic number 2, which is energy, environment, and climate change. So topic 1, we talk a lot about production and consumption of energy. Okay, and then as you can see, up to this point, the contribution of renewable is only 12% of the total. So we are still majority of the energy we consume in the world coming from actually burning the fossil fuel, either it's oil or coal. Okay, and those bring the consequences to the environment. Okay, microenvironment as well as the climate change. I think this topic are very famous and every day cited everywhere. Whenever something you see the flood and people will start to cite, oh, this is climate change. When they see the drought, they will say this is climate change. To a certain extent, whenever I look into the data that I will share with you, it's a little bit, okay, I start to think about, is it really, I mean, because as an academic, we need to still instill the doubt about whatever people say, including this climate change. So at least if we are in a position of supporting the argument, we have an idea of how to face the challenge from the opposition, the one who stand for another opinion. So, I split the topic into 4. Okay. So today I'm going to share about the first 2. Okay. And the content of this lecture exclusively taken from this report. Okay, I'm going to share that. So the book, where is it? A moment, yeah. Okay, it's this book. It's not uploaded yet. I'm going to upload it later on. But basically, I look into because it's rich of information. I'm looking into the summary of the policy synthesis report, the summary. So it's from page 2 to about 30, I think. Yeah, to 31. That's the summary. It summarized the next part where it discuss in more detail about the topic. Okay, here. So basically, topic 2 exclusively taken from this report, and I find this report is fascinating. They got a very nice data, very good plot, and I'm going to share with you later on. So the assignment 2, so we'll have a second assignment. So here you will see, you will see the change and their cause and risk and impact. Okay, we will discuss global. So it's world change, world impact. So your assignment will be doing 1, 2, 3, 4 and analyze it for each country you have assigned to. So what is observed in Indonesia, for example? What is observed in Thailand? What is observed in Singapore? Something. When another thing is what observed in Malaysia? Okay, what observed in Vietnam, for example. So I want you to localize the things and try to analyze per country. Okay, that will be assignment number 2. Okay, so let's go on. So the main point of this one is actually the influence of human to climate system is very clear. So anthropogenic mean the effect of human activity. Okay, so the consequences of the human activities on emission of greenhouse gases are the highest in the history. Now you can imagine we have been using the fossil fuel a lot over the years. I think since the Industrial Revolution, even before that, from the biomass. Okay, and then when you burn, basically the hydrocarbon, we change it to water and CO2. And if the rate of CO2 uptake is higher than the rate of production, you will expect that the CO2 will be accumulated in our atmosphere. Okay, and that one gave a widespread impact on human and natural system. Okay, so now we look into what is the observed change. Okay, what is the observed change? Okay, first one is the warming of the climate. Okay, both the land and the sea level. And this is the data. So what I've seen, the data was taken from 1850. I don't know exactly how they take the data during that time. And then the data end at 2010 here, 2010 here. Okay, it started to increase significantly from here. Okay, but fluctuating until this point. And from this point onward, it's continuously increased. Okay, so the last 3 decades, this one count then from around, this is 10, so it's from around here, 1970, 1980. Okay, the constant trend of increment is seen. And based on the data, the temperature of the land and ocean increased by close to 1 degree Celsius. And the energy, the increment of energy is actually stored in ocean. Okay, 90% of those energy is stored in ocean by increasing the temperature of the seawater. Okay, you might argue that it's quite small, 0.85. And by looking into the fluctuation, who can guarantee that it will go up, for example? Maybe it will flatten. We don't know. So this is the let's call it disbeliever of this idea. We'll talk about. Okay, we don't know. We are looking into a magnitude of very large, so close to 200 years data. Okay, 200 years data, and then we don't see the trend. Maybe this is just a normal trend. It's a random trend. Okay, that is the skeptical of climate change argument. Okay, that's number one. So number one, the most important is global warming, the change that we observe. Number two is sea level. There is a rise in sea level. So the data is taken from 1900. So you have 2010. Here you see a clearer trajectory of increment in sea level. Yeah. Okay, it's not very high, as you can see. It's just 0.2 meter. Okay, so but the consequences, as you will see later, is quite immense. Okay, and the cause of this one, because of the only explanation why you increase the sea level is you bring more water into the sea, and where the water come from, then we come up with the melting of the Arctic ice. Okay, you get melting of that ice, so you bring the liquid water into the sea, and now the level of seawater increase. So basically, it support the first change, which is the rising of the temperature, lead to the melting of the ice, and then now because of you have more water contained by the ocean, the level of the sea level in the ocean also increase. Okay, another observed change is the CO2. Okay, the CO2 coming from hydrocarbon that is burned. Hydrocarbon can be from the coal, can be from the oil. Okay, uh, this data is showing not only the CO2 but also another green house gas, which is here is methane, and this is an NOx. But the level of methane and NOx is very low. Yeah, it is in you look, the unit is ppb, is a part per billion. The NOx is also part per billion, so that's quite small. So 1,000 fraction of ppm is a billion, ppb, a billion. So they're quite small. So focus was given. Okay, the blame was then given to the CO2. And actually, the CO2 is directly related to the burning of fossil fuel. Okay. So what is CO2? CO2 is acid gas, and actually it can be we call it absorbed by the seawater. So since this is acid, okay, the acidity, the pH decreased by level of 0.1. So if you are if you understand biology and other things, the small change in pH change a lot of things. It will change the level of, for example, dissolved oxygen, the optimum growth for certain species of fish or oil animals, oil living things, or in English, will change. So the lot, okay, the lot of actually a micro change as a result of CO2 absorption. Okay, and pH, okay, pH 0.1, it is actually in the logarithmic things. Remember, the pH is log H concentration. Okay, log H plus concentration. So if you bring it to the concentration of hydrogen ion, okay, it corresponds to 26% increase of hydrogen concentration. So huge. So although if you say that the pH is only 0.1, but if you bring it back into anti-log 0.1, it corresponds to the increase in 26% of hydrogen concentration. Okay, that's the thing. So this one is in terms of the ppm. So now we'll try to link it in terms of how much actually the CO2 produced, how much actually CO2 is released to the environment. And as you can see here, there are two factors that lead to the CO2 emission. The first one is the forestry and other land use. Okay, so forestry is actually here is the depletion of the forest. Okay, depletion of the forest. What is the relation? So when you have a lot of forest, the forest will fixate CO2, so through photosynthesis, and it's become the new biomass, renewable biomass. That's the thing. Okay, that is actually giving a negative things. So I can imagine now this one, the contribution of the forest and other land use, okay, lead to actually emission of CO2 because of we consume the woods, because of deforestation, civilization grow. We use the forest land for agriculture and so on. So that's lead also to the CO2 emission. But it's probably that one is unavoidable because of the growth of the population. The fossil fuel to some extent is unavoidable as well because we need energy for surviving. But it seems that this one, it doesn't tell you well with actually the growth in population. So what happening is that as the more recently, okay, we consume much higher energy per required, and we emit substantially higher amount of CO2 to the environment. And starting from 1950, you see here dramatic increment in terms of CO2 emission. So every year it's about increment is about 2 gigaton of CO2 per year. 2 gigaton of CO2 per year. If you refer to the data of the data from the BP, actually probably because this one is up to 2010, it is not reflected. You will find out a small decrease in CO2 actually emission last year because of the pandemic. So you can relate now. This ppm concentration is because of a constant supply of CO2 to the atmosphere, and acidification here. Sorry, where is it? Acidification of the seawater. I think, yeah. It's because of absorption of the CO2 in the ocean. Okay, so that is what observed. Okay, I'll repeat again. We observe the increase in global temperature. Okay, most likely observed on the sea temperature. It's not huge. It's just 0.85 degrees Celsius of close to 200 years. But the last 30 years was like a constant increase. Okay, so it's like the global warming picking up from 1980s. Sorry, 1990s. Okay, so next what we see is the melting of the ice leading to the rising of the sea level. Okay, and this is because of the CO2 production. Okay, CO2 production is coming from two, which is the forestry and land use and fossil fuel. Okay, the constant release emission of CO2 will lead to increase in the concentration here, and some of the CO2 remains in the atmosphere. Another is actually vast majority of the CO2 will be absorbed by the seawater, as you can see here, and then the pH decreased by 0.1, corresponding to the increased concentration of H plus of about 26%. This is very high. So what is this? So what is the cause? So according to this report, the reason is because of human activities. So it reminds me if you learn in the Quran, so it said all of the bad thing happen on earth is because of the human activities. And then as a religious in Islamic view, then we believe that probably this is the pathway to the end of the day, to Yaumul Qiyamah. So it says Zaharul fasadu fil barri wal bahr bima kasabat aydin nas. It's because of the so all of the thing you see here, okay, this thing you see here is because of human activities. That's what it says there. Okay. So the cause. Okay, look here. If you read the report, they will attribute it all of the observed change, okay, due to the CO2 emission. Okay, the CO2 emission, because the other component like methane and NOx, NO2 is of a minor, of very, very small. Okay, if you look into this slide, so it shows the annual human activities that lead to greenhouse gas emission. So greenhouse gas emission, this include a lot, yeah. F gas, fluorine gas, N2O, methane, and then you have a CO2. Okay, you have CO2, As you can see, CO2 contributed to very large fraction, just about 75 percentage in the beginning, and here is close to 85%. Okay, and if you look into this data closely from 1970 to 2000, okay, you will see the total, the yearly increment is about 1.3%. And from 2000 to 2010, you see significant increment, okay, from average of about plus 1.3% to plus 2.2% yearly. So if this continue, okay, you will start to think about what is going to happen. Okay, that is basically the main argument given in this topic. Okay, so next, now we look into the contribution of the temperature change. Because you might argue that, is it really true that the global climate change is because of human activities? Okay, so if that's true, then what is the details behind that? Okay, so this is a summary of contribution. Okay, so if there is no activities of human, okay, so this is nature. So if we just count the nature activities, including, of course, including the volcanic, earthquake, those things, the tornadoes and so on, that we say is natural. So the natural activities will lead to zero change in temperature. You see it. Natural activities will lead to zero change in temperature. Then you'll see the greenhouse gases go to the right, contribution up to 85% here. So observe warming, this is the total. Is the total. Okay, that's it's around here. So we got here the contribution of the gas is positive to the right. The contribution of the human activities we can count. Some will lead to the global warming, another will cool down the atmosphere. So you see the balance here. You not take into account. The net highest contribution is still thought to be the greenhouse gases. So any human activities that emit greenhouse gases will eventually lead to the increment of the global temperature. Okay, another way to look into the impact of climate change is to the rate of precipitation. Okay, rate of okay, this is the thing. So you have an air. How to write it? You have, okay, I'll write here. Maybe you don't understand this part. Okay, you have an air. Okay, air, we have a composition of a lot. We got oxygen, we have nitrogen, you have carbon dioxide, and so on. Okay, but air can also contain, okay, the air can also contain water. Okay, that's why you have a term of relative humidity. For example, Brunei temperature might be around 30, but it's highly humid, meaning that the air contains a lot of water. And the capacity of air, so this is temperature. The capacity of air, sorry, I'll draw it here. This is capacity of air, and this is the temperature. If you increase the temperature, the capacity of air to contain water is higher. Okay, the capacity of air to contain water is higher. So meaning that if the global temperature increase, then there will be more water in the atmosphere. So now you have more water in the atmosphere. This water will go down as rain, right? So basically we change the climate. Okay, we change the climate just by looking into this basic concept. Okay, so what we see globally, you can see it here. Okay, physical system first. Okay, physical system, you see a glacier, snow, ice, okay, and or permafrost. I don't get this one. You'll see river, lakes, floods, and drought. Okay, you'll get a coastal erosion and sea level effect. And from this global map, you will see whether it will increase, decrease, and so on. You can see the frequency, the value, for example, here in Australia, the level of glacier and snow is high. Here, how to read the things. And then in some cases, we see here, for example, in somewhere. Okay, some here that the number of bar looking into the very high impact, one bar of the showing a very low impact. And then you can look into different zone in this map. Yeah. For example, North America will be affected highly by the melting of glacier. Yeah. Okay, there's a physical system. You look into biological system. Okay, this is the legend. You get an impact on the terrestrial ecosystem. This is the change of the terrestrial ecosystem. Okay, wildfire. Okay, and marine ecosystem. Okay, which one that is highly affect on the marine ecosystem? As you can see here, South America affected highly in marine ecosystem. South Africa around here in Africa also affected highly. What else? European will be affected very high, for example. Okay, and human and managed system also the consequences. Food production, sea and livelihood, health and or economic. These are the projected impact of the climate change as well. Another impact is the extreme event. I don't have the data in the report. Maybe it is in the full report. So there are change in many extreme weather and climate events since about 1950. Some of these include cold temperature extremes, actually now happening in northern China. Warm temperature extreme, it happened in Europe many times. And for us, the change in temperature, it doesn't affect much, but because of our climate, I think. But if you look into the news, for example, in Europe, many people die just because of the temperature reached 32, 35. The reason is that culturally, they're not used to that kind of temperature. So when the temperature increase to, for example, 34, they don't know how to handle it. They don't have enough ventilation in the house. Instead of having air conditioning like us here, they will have heater because you have a different way of adapting to the past environment. Housing was built 100 years, 50 years in the past, so it was designed to adapt to that kind of climate. And when with the sudden change of the climate starting from 1950s, the architecture design of the building is not well adapt to this kind of environment. That's why you'll find in news, for example, in European, Scandinavian people, many of them die just because of heat. Okay, another thing observed is extremely high sea level. Heavy precipitation mean a lot of flood. okay, in a number of regions. We've seen it happening last month in Malaysia. It's happening in almost every year in Indonesia. So that's the thing. So heavy precipitation, you can explain it as such. So you increase the temperature of the air. Increase the temperature of air. Basically, the capacity of air to contain water is higher, which also means that there will be more water to be precipitated, become rains. And the design of canals, the housing, blah, 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 was based on the past 20, 30 years. Okay, because infrastructure was designed in the past most of the time and was based on even the data of the more older data. So our infrastructure is not designed to that. The same thing actually happening in Brunei. You have the water supply issue, for example. That was built 50 years ago. Infrastructure is very old. And then probably it was built based on the data of 60, 70 years ago. And now this infrastructure has to deal with the present time, where there are a lot of changes. That is the reason why we have this thing. We don't anticipate flood. We don't anticipate the warming temperature, cold temperature, and so on and so forth.